In this final episode in our series on building scalable applications in the cloud, I'll summarize the best practices that we've discussed previously and then talk about next steps. In this final video of the series, as with the previous videos, we're going to reintroduce the reference architecture you see here and pay particular attention to the best practices summary at each of the tiers of this architecture. And we'll start with the load balancing tier. Now, the vast majority of RightScale customers use either HA Proxy or Amazon's ELB or Elastic Load Balancing service to accomplish their load balancing needs. Now, other options exist from RightScale partners such as AI Cache and Zeus, but they tend to be more suited for specialized use cases. Now, if you use the HA Proxy solution, we recommend you distribute your servers across availability zones. And this is a common theme you've heard throughout the videos in this series, and you'll hear again today. Always distribute those servers to increase the availability of your application. Larger is not always better. With AWS, you're currently going to hit a packet per second limit as your throttling factor long before the instance's CPU or memory capacities are exhausted. So if you go with an AWS M1 large, you're not going to gain a whole lot of advantage going anything larger than that for your load balancing needs. Now, we have a white paper with many additional details available at the URL shown here. Next, I'll give a recap of the best practices of the application server tier, with particular attention paid to the scalable component of that tier, the server array. Now, to have a true auto-scaling application, you need to have your application servers come up with no manual intervention. The server launch needs to be fully automated. Each of those application servers needs to download common code so that all the application servers within the tier are identical. You don't want to have problems caused by a one-off situation. You need to use load testing to determine what your auto-scaling triggers are. Perhaps your application is CPU bound or memory bound. You need to figure out what are the triggers you need to use to scale up and to scale down. And speaking of scaling up and scaling down, you should scale up and scale down conservatively. And that means always make sure you have enough infrastructure in place to keep ahead of the demand. The worst case that can happen is you may have a few servers running for an extra hour that they didn't need to be there. And in the grand scheme of things, that should be fairly minimal. You want to distribute that array across availability zones. Again, increase the availability of your application. And you want to use array size minimums and maximums appropriately to help save your costs. And lastly, you want to load test to determine the correct instance size for your array servers. Many of our customers have great success with AWS's M1 large for their array servers, but for your particular application, they may not be a good fit, and the best way to figure that out is to do load testing. Next, we'll summarize the best practices of the caching tier. Now, when it comes to the caching tier, we always recommend you use a separate, dedicated, distributed cache. And what we mean by that is that we recommend you keep the application server tier and the caching server tier on different servers. If you do decide to have your caching server co-resident with your application server to save costs, then we recommend you do not use a distributed cache due to the database and application disruption that will be caused in a scalable array as these caching servers constantly jumping into and out of the caching pool. We recommend that you weight your caching servers across all availability zones. Again, this is to help increase the availability of your overall application. We recommend you determine the memory caching footprint of your application ahead of time to help determine the server count. And over-provision whenever possible. Give yourself room to grow so that you do not need to quickly add additional capacity if things go well. Set your TTLs to expire, your time to live. The data objects that live in those caching servers should always expire at some point. If you do need to add additional caching servers, the hashing algorithm that determines which objects go to which caching servers may change, and as such, you may end out with data objects that reside in memory and are never accessed. Therefore, we always recommend you set those TTLs to expire. And lastly, we'll give a brief recap of the best practices of the database tier. Now, for the database tier, we recommend that you use a single master and multiple slaves if budget permits, and that you distribute this master and this slave or slaves across availability zones. Again, the same common theme here. Use those availability zones to increase the overall availability of your application. We recommend that you do not use the ephemeral storage or the local or transient storage that's attached to the instance. If that instance was to go away for whatever reason, you would lose access to that storage as well. We recommend that you back up frequently as is practical, and use whatever your cloud of choice's flavor is of persistent, redundant storage for those backups. We also recommend that you use load testing to determine the proper instance size for your database. There's a vast array of instance sizes available in all the clouds out there, and determining the proper one can be a tricky endeavor, and load testing is the best way to determine this. Now, if your initial choice of database size doesn't prove to be sufficient over time, we recommend that you scale vertically when possible. And that's basically the concept of moving from a smaller instance size to a larger instance size. Now, if vertical scaling no longer becomes an option as well, there are horizontal scaling options. For example, multiple read slaves. and that's where you can use multiple read slaves to help alleviate some of the read load on your database. You can also use sharding, which is a shared nothing architecture, and RightScale has a technology partner that can assist you in setting up a sharded implementation. And lastly, NoSQL solutions. If your application lends itself to a NoSQL solution, they can show great benefit and assist you with scaling out your database tier. In conclusion, this kind of brings us to the question of, so what's the best solution? Well, as is typical in a lot of technology-based discussions, the answer really is, it depends. There are a lot of variables involved here, and every application is different, and as such, there really is no one-size-fits-all solution. However, a lot of scalable environments share some common underlying architectural concepts, and components of a reference architecture, such as the one discussed in this series of videos, can be used as a starting point, with tweaks and modifications made to accommodate the unique characteristics of the application itself, as well as the load and traffic patterns that it may face. But, with that said, if your architecture includes a combination of the components seen here, RightScale predefined assets exist to assist you in building your scalable application, with new technologies continually being added to the platform. I hope you enjoyed this video series on building scalable applications in the cloud. To get started in the cloud, sign up for our free edition at rightscale.com or call us at 1-866-720-0208. Thanks very much for watching.